Okay, so let's look at some real world implementation of something what we discussed today.
What we'll be talking today is machine learning, business rules, and optimization for flash sale pricing. So let's start with the riddle. We have 6 dresses here in different shades of green. So since we have highly sophisticated melodians here, let's imagine that we need to sell those 6 dresses to maximize revenue. So naturally we need to decide, like we need to assign prices to each dress. We need to guess how well they will be perceived and sold. Now let's, to make it complicated, imagine that we haven't seen those dresses before, which is true in this case. And there is a lot of constraints surrounding each dress. We want to obviously make profit, but there is also other constraints. We cannot sell it lower than a certain price.
Igor, just before you continue, I just probably should tell you, Igor works for a company called guild.com.
I'll get to it. I'll get to it. I just wanted to give a feeling what we do day in and day out. So as Jacob preempted me, I work for guild.com. We are a flash sale company. We sell high fashion retail in curated sales. And I'll talk some more about it. But this particular project was intended to help our merchants to price items, thousands of prices of items every day, to fulfill their business objectives. We use combination of machine learning, business rules, and multi-objective optimization. On predictive analytics part, we used R and XGBoost, and I'll talk a little more about it. More relevant to this particular gathering, for business rules optimization, we use open rules engine to optimize according to our business objectives. So a little introduction to Guild. Guild pioneered flash sales concept in the United States. Flash sales meaning every day we sell a lot of collections of fashion items at very good price. The trick is, or the catch is, those items available for very limited time. Most of our sales last 72 hours, but most of the items are sold within the first 2 hours of the sale. We don't change prices while sale is going live, and most of the products we sell we haven't seen before. So we get them, we price them very competitively, we sell them. Meaning that we need to get pricing right. We will not have a do-over, we will not have like another chance. We need to quickly assign optimal prices, sell as much as we can, and be ready for the next day to process thousands of new items. This concept of flash sale was expanded. Guild started with like women apparel, now it deals with men, kids, home. We like kind of competing with Groupon, selling offers on Guild City, and we have big international presence. So this is roughly a summary of scope of the issue. We have millions of active members, and when I say active, some of them are super active, in the sense they visit our site every single day, which makes sense because every day it's a new offering, new site, and so on. More relevant to this discussion, every day we run 400 new sales, meaning there are people who put 400 curated collections, putting the combination of items. Most of them we've seen first time, and they need to price them competitively, effectively, and so on. So now, putting all this aside, what's the games that we play? Essentially, we need to balance supply and demand. So supply are the items that we sell. Demand are our sophisticated members that crave what we sell. So what we need to find is a balance between our prices and their demand. The cost of getting it wrong, especially for dynamic business as ours, is super high. Because what we noticed is that item has 30% lift when it goes on sale for the first time.
30%.
lift,
Oh,
meaning 30% better chance of being sold, controlling for the same price and so on. Meaning people see it, they recognize it's a fresh item, it just appeared on site, there is marketing that goes with it, we get much more traffic on this particular sale, so it's like now or never. If we misprice it, people will leave disappointed, we lose the sale, and moreover, it kind of like damages perception of our site as being a place for exciting stuff at great prices. So we need to get it right. Objectives for this exercise were to predict demand for every product in a given sale for all possible prices. If we can do that, then we can pick optimal price.
you have to explain later how you do that.
Exactly, that's a point. So now, let's assume that we've done it. So we can predict demand for every item, for every price. From that point on, we need to find the best combination, the best mix to maximize revenue, sell-through, margin, or a combination. Last part, which is probably most difficult because it's not technical, is to present our findings to business users who are essentially merchants. They don't care about optimization, machine learning, or business rules. What they need to know, will this, let's say, collection sell or not? Or will they satisfy their, let's say, revenue objectives? And they also need to trust what we tell them. So not only we need to do all those two things, which is so complicated, we need to do it in a way that they will trust us. And they being domain experts, many years in fashion industry, they know that fashion is unpredictable, they know that fashion consumers are unpredictable, and here we come telling that we can predict all that, and we can do better than they have been doing all those years by setting prices manually. So this is how it's done. No magic here. Most of the effort and time spent in data prep. We try to collect everything that we know about item. Since a lot of items are new, we see them for the first time. We also add everything that we know about history. So we don't have much history about this particular item, but we've been dealing with similar items for years now. Also, the good part and bad part, we sell a lot of different items. So somewhere amongst the millions of products that we've been selling, there are some products that are possibly similar to this one. Keeping in mind that it's old-fashioned and it changes very quickly. Then, collecting all this data, we predict demand. So we try to build a model that uses this all to predict demand at a different price level.
How do you predict them? It's you.
Coming up.
Experts? Or you do?
No, machine learning.
What?
Machine learning.
Okay.
I'll get
Okay.
it. Then, assuming we've done that, now it's like we need to pick optimal price combination out of millions possible price combinations for every sale. And then, last part, we need to validate the results somehow. The problem is we cannot do proper A/B testing. Like we put something on sale, we price items, we cannot show different prices to different customers. Meaning deciding what would have happened if we made another pricing decision is tricky by itself. And I'll get to it, how we try.
Why can't you do that?
Business thinks it would be detrimental if you see a dress that you like, and so you'll call your friend and say,
It's a different price.
I see this dress, it's like $1,000, and he says, oh, that's weird because I see it for 800. And then we lose both of you, and then all trouble. So that is not, again, being data scientist, I was vouching heavily for this because this would give me the most honest A/B testing.
Right.
But since I cannot do that, I had to come up with something else. So this is a process how it happens. Data is collected in an operational database, and it flows into data warehouse that contains all the historical data since the beginning of time. Having that, and beginning of time in real times is 2007. So I don't get too excited. Plus, I discount most of it because, like, in fashion, whatever happened more than 2 years ago doesn't exist. So roughly it's like sliding window of 2 years. So having that, I assemble training data, meaning all products and all the sales with a known demand. When sale completed, essentially reality, actually, we know how many items we sold, and all the attributes of those items and all the attributes of sales and so on. So then I apply some like first layer of business rules. Like for example, of all the switch data that we have, how much of it is representative? So there is a lot of rules codified in this original SQL, like discards all sales, they were not representative, we heavily subsidize them and so on. Those products are not representative, we will not have anything like that, and things like that. So we try to smooth different zigzags of like fashion craziness just to distill signal that is repeatable, that can be used to predict the future. Then, having this data, like we transform it somewhat, like one hot and cold and like all that, deal with long tail categoricals and things like that. If there are questions, I can cover it. But as a result of that, we feed it to R and use package XGBoost to do like machine learning magic to predict demand on future products and future sales. Unfortunately, so XGBoost is variation of boosted trees, random forest. Unfortunately, it's a black box model. So whenever this model tells, you'll sell this product in this sale at this price, this many pieces, it's pretty hard to tell our business users why it thinks so.
That's what I was asking, when you say you're going to predict the price, I was wondering how, do you have some kind of algorithm, do you use analytics, or you use forecasting packages, what are you using there?
XGBoost. XGBoost. Yeah. So essentially, it's a program, I feed it everything that I know about sale, product, and so on. It spits out predicted demand.
It's all magic. Okay.
Yes, so it's, in a way it's black box. Everything that I tell you is compartmentalized, meaning optimization piece doesn't know about prediction piece doesn't know about data collection, which allows me very easily to substitute parts. There are white box ways to do prediction, which are not as good as XGBoost, but they have one huge advantage. Let's say decision tree. It means I can walk my business user, so to say. Let's take this particular shoe. I think you're not going to sell it. Here is why. And it's not me, it's true. At this point they faint and so on, but at least I can give them some idea. Like, this shoe is yellow. You price it over $600. We never sold yellow shoe for over $600. So there. Moreover, you try to sell it on Saturday. Saturday is traditionally slow day, so there is no way you can sell it at this price. Once we establish basic trust, and they realize that, yes, there is some sense in what you predicted. But even better, when we went live and they saw that even if they don't understand how those demands are predicted, test group, meaning algorithmically set price, beats manual group, then they started to kind of accept the magic. And we'll talk about it some more. And
sorry, Igor, when you say you're predicting demand, do you mean you're predicting demand? You said there's a curve of different price points, or is it?
Coming up.
Okay.
2 slides later. But back to our process. So we have merchant. Merchant job finally becomes what they should have been doing all those years. Instead of like setting prices for 1,000 items every day, day in and day out, now they can concentrate more on creating those curated collections. Because they need to know like which items they should put together. So that's really like creative part of their job. Moreover, less creative part of their job is to understand what they try to achieve. Do they try to squeeze as much revenue as possible? Do they try to sell as many items as possible? Do they try to increase margin? And that differs all the time, or combination. And also, what kind of other criteria they can put there. So they say, Sometimes I want to sell as many items as possible, but I'm not ready to take less than 10% of a margin. Or they can tell, I can go into negative margin. I want to get rid of stuff. Or they say, like, give me like most money possible. Like, do whatever. So they provide me with future data, meaning they tell me which items they want to go in which sale, and on which days they want this sale to go live. They provide prices, meaning they price, since we're talking about test and control, they price part of the collection manually, as they did before. So we have something to compare with. And they set up priorities and constraints. Now, I use models that I built before using historical data to predict demand on future data. So now I'm in unknown territory. Now I'm just seeing future. And I generate all possible prices for all the items within constraints that they gave me. So for example, they say, we want to have at least 40% margin, and we want to have at least 35% discount from MSRP. This gives me window. And I fill this window with all possible price points. That still would be simple. But what I'll talk about later, we found some interesting phenomena which forces me not only to do it for every possible price, but for all possible totals of all possible products in the sale, which creates like data explosion, probably like number of products in the sale multiplied by about 10,000. But having that, I apply the model predict demand, and then I feed all possible combinations, all possible prices on all possible products to optimizer, which generates optimal combination of prices based on criteria that we set up. Those prices go live, sale happens. Fortunately for me, that's excitement of my job, everything happens very quickly. So literally next day, I know if I won or lost. Or rather like my algorithm in this case. And then based on that, do they like smile at me or yell at me, like I tweak algorithm, and then I get to play another day. Over the course of many sales, we compare test group with control group. So far, control group meaning, test group, meaning algorithmically set prices are winning handily. So I'm very happy, that's why I'm here sharing with you all this good news. Before we get to price curves and everything, I want to talk about data preparation, because that's essentially what we do all day versus what everything thinks. Everybody thinks what we do all day, meaning we prepare data. So for this case, we combine everything that we know about the product, meaning like obvious stuff like brand, category, material, color, all that. Then prices, what manufacturer thinks it should cost, what we bought it for, and so on. Like if we sold it before, what was the price, how did it perform, and so on. We combine it with sale attributes. So this sale, does it have products of like single brand, or it's mixed bag? Is it like single category, multiple category? Then when this sale is running, like which day? Because days are not created equal, as it turned out. How it's relevant towards like the year. So right now, right after Independence Day, it could be like slow season. So algorithm looks back and combines those attributes to see how it affects demand. Then, famous price curve. So but this is like simple textbook case, which happens sometimes but not always. So this is a case when as we increase the price, demand kind of like falls. At higher price, we'll sell less, but at some point, like revenue will, there is a like maximum of the revenue, and this is theoretically what we should be selling it for. Unfortunately, in most cases, it's not as simple as this. First of all, it would not be smooth linear curve. Like demand like jumps up and down. because like fashion is unpredictable. Sometimes you can price it very high and people will buy more of it because they would perceive it to be premium. Sometimes the other way around. You need to make it much cheaper than everything else, and then people will like, flock. But it could be the other way around. They would say, if it's cheap, it's bad, and so on. So it must be something wrong about it. In our case, everything, all those sentiments are amplified because it's flash sale. People need to make decisions very fast. So they might just decide, like in restaurant, nobody orders like the most cheap wine because perception, it must be bad. So same thing, making product like super cheap can increase demand. So we're doing it for nothing. We're like losing money and we are not selling this much. Then, the goal of price optimization is optimize per product, essentially finding this green dot, but most importantly optimizing per sale. We need to optimize for success of the whole sale, not for individual product. Let's say if we make one product super cheap, everybody would be buying this particular product and not anything else. Meaning we would be like killing ourselves. We would be like losing money on every sale. So we need to find a combination. We need to iterate very quickly. Meaning our timeline is super fast. In preparation, sale goes live every noon. It's like our release day, every day. Sometimes our merchants have like 1 or 2 hours before sale goes live to finalize, make up of the sale, pricing, everything else. Sometimes they also use this time to check competitive environment because algorithm suggested something, but our competitors RuleML, which essentially who are doing exactly the same thing, might be like up to something and they could overlap. Our offerings might overlap. If their price is better, it will not look good. Also, they need to finalize rules, what they're trying to achieve. And that's example of the business rules that they're using. So they say, if it's initial sale for the product, we want this margin, this revenue, and this sales through. If it's repeat, meaning that the product we already tried to sell before, parameters are different. And if it's exit, meaning we just try to get rid of this product altogether, those are parameters. And sometimes sale is a collection of different types of the product. Then they provide optimization weights. They say, for this particular sale, like I want revenue to cost this much, margin this much, and like sell through this much. So this way they can combine priorities. And so here is like sample result for a sale. If and we used like open rules for that to, based on the criteria specified, to put how results would look if we optimize strictly for revenue, then strictly for margin, strictly for sales through. And last line is interesting because it shows that optimizing for sales through doesn't actually make sense because you would squeeze extra 1% for sales through, but you would sacrifice 10% of margin, which is terrible. But it's a good insight to our business users. Meaning, essentially what it tells them, we understand that you want to sell a lot of items, but discounting them by a lot would not help much. You'll just lose money, which is something they didn't know before because they were essentially flying blind. And so when all said and done, so the model was built.
So why actually do you allow users, business users, to interact with the system and to set goals? I mean, the ultimate goal of the company would be probably to get the most money out of them, considering different variables that the cost for the stock and stuff like that, right? So you could probably make the model a little more complex and just avoid the user interaction, but you still have the user interaction. Why though?
You would think so.
Yes.
We made a survey among our top executives about what they think current company priorities are. Like it was like blind survey. It turns out that they are not in agreement of what priority should be. So what they agree is that it changes from day to day and so on. So they could not agree, and that would simplify things a lot. But they couldn't agree that like revenue is the most important. That's clear. Also, like it depends where like in the business circle we are. So to create this, I guess I would need to say like AI bots that would listen to their like emails and everything, all this noise, and decide, oh, right now we are going for margin, fantastic.
Yes.
Like, next week it will be revenue. So this is a little too complicated.
Okay.
So, plus we need to let executives to do something. So that should be their jobs. They need to decide what they want to achieve, and then once they're there, we'll. But also, like previous slides, so sometimes it tells them that their objectives actually don't make sense. Essentially, it tells them, you think you're going for sell-through and margin. Go for revenue. You'll be like much better.
Yeah.
Which again is a huge insight for them.
Igor, is there any aspect of this that is at the buyer level, like you're more likely to if you pack? I know you don't want to change prices, but these 4 dresses, you look for green dresses, I look for green dresses, but the combination that's more applicable for you, and you're a member, and you're one of those 4.7 million or whatever the number was.
9.7.
Huh?
9.7.
Oh, there, it's grown. It's grown just since the beginning of the presentation.
Yes, ideally we would like to apply this at the point of buying. Unfortunately, at that point we don't have any kind of information. I mean, to do intelligent decisions, and we try to push it as far like upstream, down the stream as possible. Because buying is when it won't happen. Unfortunately, it's in our business. It's like flash and so on. Often, our buyers make decisions based on like they want those 500 dresses from I don't know Prada or not, and they say, well, Prada is a good brand, so like yes, but that's the level of details that they have. So to predict how those dresses with unknown attributes will perform when put on sale in unknown date in the future is virtually impossible. So what we do instead, we look at historical data and we say, from this brand to this category, historically, whatever they offer you is 70% good, 30% crap. I hope I'm not video recording. So, so what we, never mind. So what we tell them, look at what they offer you and grade it into A, B, and C, meaning popular, neutral, and risky. Every dress will have its buyer, but don't buy everything uniformly. Like keep in mind that traditional breakdown is like this. So instead of this, optimization and prediction, we give them simplified, essentially historical histogram, meaning take whatever they offer you, pick 70% of the stuff that is good. Like in other words, throw away 30% of the stuff that you think will not perform as well. Remaining divide into like 3 categories, and then buy more of the stuff that you think is popular, and so on. So it's pretty obvious, but it was new in our buying process because what we saw that historically they buy uniformly, just betting if brand is good, outcome will be good. But we saw, I mean, now having a lot of data, we saw that it's not. And you think about it, it's a game that they play. Say a seller tries to maximize their profit, I mean brands that we are dealing with, at the same time kind of like minimizing quality of the stuff that they give us. We try to maximize quality of the stuff that we get and minimize price that we pay for it. Out of 2 sides, and unfortunately we are at information disadvantage. They know how those products perform. We don't. Meaning, our best bet is to use histories that we collect just to equip our buyers and say, hey, like, here is what you should expect from items that you think is popular, like historically. You'll sell it in 4 exposures at this price. Okay. Back to business.
Oh.
So,
did you actually go through that slide? 'Cause I was interested in the pricing relative to the other
oh yeah,
items.
that's what I should mention. So, the biggest discovery for us, which it turns out already has been discovered by Professor Simca Levy and his team in MIT, is that one of the biggest predictors of how item will perform besides its own price and other attributes, is what else is within the same sale. Which I'm going to illustrate with this brilliant example of ball and pen. So let's say assume we have only two items on sale. One is ball, another is pen. Let's say we have only two possible prices for each. We can sell ball at $2 and $4 and pen at $1 and $3. If we feed it into predictive algorithm like mine, it will spit out demands, and it turns out that for the same item at the same price, demand could be different depending on what else is on sale. Like essentially how cost of this item relevant to, let's say, to average of prices of everything else that is on sale, which is essentially how it relates to the total number of all the prices in the collection. So this was interesting discovery in the sense that it created all this data explosion. Now I need to predict not only for every single price within constraints that they gave me, but for all the possible totals. Finding all the possible totals is a tricky problem by itself. It could be considered as an optimization problem. But I worked it around by just saying all possible totals are somewhere between sum of max prices for all the items and sum of lowest prices for all the items. So what should have been this becomes this, like all possible prices. Some of those totals are unattainable, but I kick the can down to optimization part to remove unobtainable totals. So this brings us to essentially multiple knapsack problem. All items might be priced. Each item should have only one price, and sum of all prices should equal to one and only one total, which say like total should be equal to total. Having that, this is MassProg definition of the problem. Just to say in words, this is, let's say, if I was solving it with something that understands MassProg, data would look like this for my ball and pen problem. And essentially, what we were doing is similar to that. Unfortunately, it turns out no ready-to-use tool, and we tried GLPK, LPSolve, like CoinSweep, and so on, could solve this problem as is. But with the help of open rules, we found out that if we break problem into multiple parallel problems, each individual problem for a fixed total can be solved pretty quickly. So we modeled the problem using open rules, and if somebody in this audience can tell us how to solve original problem without dividing it into pieces, I would be very curious. We use constraint solvers to validate the problem correctness and to find local solution for every fixed total. Then, having all those solutions, we pick the ones that satisfy us objectives that are set by business users. That's pretty much it. So, like, OpenRule solves thousands of subproblems. So, for every possible total, it solves this problem, and then it picks optimal. So, to conclude, to achieve what we had to do, we had to combine like business rules, machine learning, and optimization. To first predict demand, and second to find combination of prices that satisfies constraints set by business users. It turns out that the problems seemed like pretty novel, but it turns out that all components were already available. I mean, machine learning is a well-known part. If not for the whole black box situation, it would be even better. Optimization tools turned out to be available as soon as we figure out the task needs to be broken into tens of thousands individual subtasks. And then there are frameworks to express business rules in a coherent manner and feed it to optimization and so on. So despite everything, like all components being available, we had to assemble them in a creative way to achieve what we needed. And the result was pretty good. That's not me, but any questions are appreciated.
So is there any intuition behind this relative pricing? I mean, is it just the fact that you need to have something in there that's sort of relatively high priced that people don't really want, but makes it feel better that what they really want is cheaper?
There is some of that.
Yeah.
And originally, when we just started presenting it to business users, they were surprised. They say, how come your price is so high if we didn't sell it last time at lower price? And then thinking about it, I thought,
It's kind of a sacrifice, right?
exactly. But in a sense, it's not a bad product. It's unique. Meaning, when buyer finally comes and spots it, and it's the right buyer, they will probably buy it at slightly higher price. And when I say like we make them more expensive, it's still good prices. Meaning there is elasticity on some products and not on the other. Meaning we didn't sell it, but at higher price, I mean, it will find its indicated buyer. But if not, at the very least, it will make everything else look good. The same way is the other way around. Some products, they need additional boost by making them cheaper. We just say, we understand it's yellow, all right, we made a bad buying decision. But still, it's half price from like black one, so there.
A follow-up question to this one. Would you consider a time window where you would say, I have products to sell, but I know that if I wait 2 days, I'll be able to package them in a set of products which will push the price of the overall set higher?
We don't optimize for that, because that would create too long a window and like uncertainty. Because often we're bound by how many times and how often we can expose certain product. So when brands deal with us, but sometimes they put like certain riders. You can sell this stuff only every 6 months or so. Meaning, we know if we don't sell it now, we'll have to sit on it for like 6 months, which puts additional pressure and it answers your question. Like sometimes there are contexts that buyers know. They say, all right, we need to sell it quickly right now, or we'll have to hold it forever. I should mention that Guild takes responsibilities. Essentially, we pay money upfront in most of the cases. So, which means we invest money. If we don't sell it, it's our money sitting somewhere in warehouse.
What would be your window?
We try to sell pretty much everything in like several exposures max.
That's several days?
Several sales. Sale is events that lasts up to 3 days. But how often we can put those sales depends on individual project. Some of them we can put on sale right away. It usually doesn't make sense. But some of them we have to do.
Question.
So you showed like an original price with a line through it and then a sale price.
Yes.
Is that a factor in?
Yes, big one. Recently, like Amazon decided to phase it out. They say it's irrelevant. We find it's very.
So are those original prices, are they fake or are they?
No, they actually matter. Moreover, like we are legally obligated to check that those prices are real MSRPs. Meaning we need to find retailers that conform, that actually sell at those prices and like that. If we cannot find it, we cannot do this strike-through price.
So speaking of models, I mean, you have human models here, right? They're modeling the clothes. I mean, is there a correlation there between, you know, like certain models always sell, no matter what they're wearing, it always sells better than others?
That's I would be happy to check. Different ways possible, but it turns out that this information is not codified. I don't have information. But what I did put in the model initially is who made buying decision and who made selling decision. It turns out that different buyers have different effect. Meaning I see that this person makes consistently better buying decisions, and whatever she bought sells much better. That's right.
My question is related to the phase of prediction. What do you think of using, for example, Bayesian network techniques that can give some insight on the decision process, an explanation of how decisions are made?
I tried it a while ago. It didn't perform as well as XGBoost. Maybe somebody else would get better results. So that's why I keep it open so I can tear apart XGBoost, put something else. I heard that like hierarchical Bayesian approach is very promising, but again, I couldn't make it perform better as it is.
Last question. Oh, okay, go ahead.
If you have any specific algorithm in the optimization part, or do you use the states of the
I use open rules as a buffer, as interface, and then open rule can call different algorithms. So we try it with JLPK, coin, and something else.
Yeah.
So in other words, my stuff is like shielded by interface.
From this perspective, it's very good lesson for standardization. We use the JSR 331 standard, and what it does, it can we can switch between different implementation without changing one character in generated model. So we tried one implementation, and it took more than 1 hour. We tried another implementation, what usually worse than the first one. It took like 10 minutes, and we tried coin at the end of the day. What doesn't have the best reputation, suddenly it worked for 1 minute. So it's in this business, usually you cannot define winners and losers from performance. It depends on the problem. And we just experimenting with this standardization gave us a big boost here. One more question.
Yeah, so what happens, I mean, I think people already know, and other people will assume that dynamic pricing is going on. So meaning that the price might change over time, and so they might think, well, let's wait another days and see how the price changes, right? So would you consider, how do you take it into account? That, I mean, people will know that dynamic pricing is going on, and that will affect their buying behavior as well.
Yes, but in this case, I'm kind of like protected from this because people know that price will stay the same for the duration of the sale, and then you may not see this item for a while.
Okay.
So this flash model makes it simple.
Okay.
But yes,
You might not see it.
some business model train customers, like wait and see
Yes.
and so on. Moreover, like interestingly, sometimes algorithm recommends raising prices, which was surprise to our merchants. But it said, so next time we put it on sale, the price might actually be higher, which comes as a surprise to merchants and users. But hey, algo says that you'll sell more if you make it more expensive.
Okay, we have to finish this with one good note. Igor did not tell it, but DecisionCAMP was one of the hottest company in the different lists in retail for the last 3 years. This year, it finally got acquired by T7.
HBC, Hudson Bay Company is at home.
So, but probably technology playing the last role in this process, and its intellectual property was acquired also very important. And you can ask more questions in the next 5 minutes informally, and in 5 minutes we start the last presentation of the day before panel, and James will present.
Are you going to take a coffee break or not?
If somebody wants, just if you want, you can take coffee and you continue.